Welcome to the dawn of the Silicon Age. Today, we're dissecting the machine that launched the PC revolution, the Altair 8800, powered by Intel's legendary 8-bit microprocessor, the 8080. With a 64 kilobyte address space and a 2 MHz clock, the 8080 was a masterpiece of mid-70s engineering. To write code here, you have to think in registers and system vectors. Under CP/M, our programs live in the TPA. We interface with the hardware through the BDOS, the basic disk operating system, by calling the entry vector at memory address 5. For our hello world, we load the 16-bit address of our string into the DE register pair. Then, we move function code 9, the print string service, into the C register. Executing call 5 transfers control to the BDOS. It reads our C register, finds function 9, and begins streaming bytes from the address in DE to the console output. The string is terminated not by a null byte, but by a $sign. Once the BDOS hits that character, it returns control, and we terminate the program by calling function 0. You've just interfaced with the foundations of computing. The architecture is bare bones, the hardware barely more than a frame to hold the chips, and the tools feel like they were carved out of stone. But this is where it all began. These simple circuits and crude utilities lit the fuse that became the personal computer revolution, inviting anyone curious enough to tinker to reshape the world.